Okay, so today we're going to be looking at writing exact values for trigonometric ratios of special angles. So the special angles are 30, 45, and 60 degrees. And for these angles, you can determine exact values of trig ratios. Now, exact values are numbers that are not approximations. So integers, fractions, radicals are all examples of exact values. We've seen some exact values in the past few lessons, and we'll continue to see this for the above angles. Now, remember, we can use the quadrants and the cast rule to help us identify the signs of trig ratios in each quadrant. So you need to think about what quadrant those ratios are occurring in. So, you know, if you have 192 degrees, two of the trig ratios are going to be negative and only one of them will be positive. So you have to kind of think about that. The trig ratio for the principal angles can be written using the reference angles and the signs from the quadrants. So those are the two things you need to know. So you have to use the cast rule and you need to use the reference angles, okay? By using right triangles with sides x, y, and r, and the angle being theta, the reference angle, we can write exact values for each trig ratio. So we're going to learn some special triangles. And these special triangles are going to have these angles 30, 45, and 60 degrees. It's actually only two triangles we're learning because the 45-degree triangle, well, a triangle adds up to 180. So if you have a right angle triangle with a 45-degree angle, then the other one must also be 45. And if you have a right angle triangle and one of the angles is 60, then the other one's going to be 30. So the 30 and the 60 special triangle are actually the same thing. Okay? So let's scoot me up here. And I just want to erase that silly little green line there. And I want to get to a better color. So we're going to use this diagram to determine the exact primary trig ratios of 60 degrees. So if we look at this triangle, this 60-degree triangle, and we see that at point A must be at, well, x is 1, y, right? We need to first figure out what y is. We have the hypotenuse given as 2. So we're going to figure out what y is equal to. Okay, so if I look at that right angle triangle here, we know our hypotenuse, we know one of our sides, and we want to find out what y is. So the first thing we're going to do is find out what y is. So r squared is equal to x squared plus y squared. R squared is 2 squared. X squared is 1 squared, and we're looking for y squared. We're going to move that over. 2 squared is 4. 1 squared is 1, so when we move it over, we'll subtract it. And that will equal y squared. Now we're going to have to take the square root of both sides. So that tells me that y equals square root of 3. Okay, so now we have all three of our values. We know that r equals 2, x equals 1, and y equals root 3. So we have all three of our sides of our triangle. So we're going to figure out the exact primary trig ratio for 60 degrees. So looking at this, sine of 60, sine is equal to y over r. So that is root 3 over r. Oh, sorry, I know the value for r, so I can put that in. Root 3 over 2, okay. Cos of 60 degrees is equal to x over r. So that is 1 over 2. And tan of 60 degrees is equal to y over x. So y is root 3 and x is 1. So it's equal to root 3. So these are the primary trig ratios for 60 degrees. Now, remember, I said that if you have a 60-degree triangle, a right triangle, that means that the other degree in the triangle is 30 degrees. So we actually have the 3 sides of that 30-degree triangle. So if I have it here, if this is 60, this is 30. The sides are the same, 2, 1, and root 3. The only difference is I'm now looking from a different angle. So I want to probably think about my SOHCAHTOA, not my x and y and r, to figure those out. So we have all the sides. So sine of 30 degrees, well, that's going to be my opposite over hypotenuse. Opposite 30 is 1, so it'll be 1 over 2. 2 is my hypotenuse. Cos of 30 is adjacent over hypotenuse. So my adjacent is root 3, and that will be over 2. And tan of 30 is equal to opposite over adjacent. So my opposite is 1, my adjacent is root 3. Now, I cannot leave that radical on the bottom. I need to rationalize the denominator. So root 3 over root 3. So when I multiply that through, I get root 3 over 3. Okay? Now, what do you notice? Well, what you should notice is that sine 30 is equal to cos of 60. And you should notice that cos of 30 equals sine of 60. Oops, let me write that pretty. And tan of 30 is equal to the reciprocal of tan of 60. So there is a relationship there with those triangles, but you only really need to know one of those triangles, and you know both, okay? So we can also use this idea for a 45-degree angle. So let's take a look at that. With a 45-degree angle, so that would be here. The hypotenuse, and I'm going to change this because I actually say that the hypotenuse would be 2 and both sides would be 1, okay? Because I prefer to use those values when I'm doing my exact values, okay? So when I do that, this would be my 45-degree angle triangle. So my hypotenuse is root 2 and each side is 1. Now, how do I know that? Well, c squared is equal to a squared plus b squared. C squared is equal to 1 squared plus 1 squared. C squared equals 2. So from that, c equals root 2. Okay? So if I have sides of 1 and 1. Now, we just did the 30 and 60-degree triangles. So we'll just put their values in. So 30 has an adjacent side of root 3 and an opposite side of 1 and the hypotenuse of 2. With 60, it's got a hypotenuse of 2, an adjacent side of 1, and an opposite side of 3. Same triangle, just on its side. So we're going to use these 3 triangles to fill in the following chart. And then these are going to be our exact values for those. Once we have these exact values, we can use them whenever 60, 45, or 30 is a reference angle. And that use them and the Cast law to determine what the trig ratio is. So for sine 30, sine 30 is going to be 1 over 2 because it's opposite over hypotenuse. Cos 30 would be root 3 over 2 because it's adjacent over hypotenuse. And tan 30 would be 1 over root 3, but we would prefer to write that as root 3 over 3, okay, because we don't want a radical in the denominator. For sine of 45, it's 1 over root 2, but again, we want to write that as 2 over root 2 because we do not want, oops, sorry, my apologies. We want that to write that as root 2 over 2 because we do not want a radical in the denominator. Cos of 45 is the same thing, 1 over root 2, which is equal to root 2 over 2 by rationalizing the denominator. And tan of 45, well, it's going to be opposite over adjacent, so it's equal to 1. For 60, and we learned this on the last page, 60, sine theta is going to be the same as cos theta of 30, so it's going to be root 3 over 2. Cos theta, we learned this on the other page, is 1/2, and tan of 60 is root 3. So this is a table, should put some thought into remembering this and those triangles because they become very useful. These are what we call exact values. So when it says exact values, leave them in this form. Leave them as fractions with radicals, but do not give me a repeating decimal for these, or non-repeating decimal, sorry. Okay, so how do we do this? How do we use this to solve problems? So we're going to determine the exact value of each, find the quadrant to identify the sine, and get the reference angle to use special triangles. So sine of 135. 135 is in the second quadrant because it goes from 90 to 180. Okay? According to the cast rule, sine is positive in quadrant 2. Okay? So we also would figure out our reference angle in that quadrant would be 180 minus 135 degrees, which is equal to 45 degrees. So it's going to be positive. It's in quadrant 2, so sine of 135 degrees, its exact value will be the same as sine of 45 degrees, and it will be positive, and it will be root 2 over 2. Okay, sorry. Now let's look at tan 135. Same quadrant. However, if I look at that one, in quadrant 2, tan is negative. Okay, the reference angle is 180 minus 135, which is 45 degrees. So tan of 135 will equal a negative tan of 45. Negative because it's in that quadrant, okay? So it will be negative 1. And we know from up here that tan of 45 is equal to 1, okay? Tan of 300. So let's sketch that out. So 300 is going to be greater than 270 and less than 360, so it'll be in quadrant 4, right? So, quadrant 4. I guess I should actually write a 4, not a 6. I don't know what's going on there. So we're in quadrant 4. So in quadrant 4, thinking about the cast law, tan is negative, okay? Now the reference angle is 360 minus 300, which is 60 degrees. So tan 300 will equal negative tan 60, which is, if we look at our table, tan of 60 was root 3, so it'll be negative root 3. And that is the exact value. Okay, so you have to remember your cast law, right? Where each thing is positive or negative in order to solve these. Okay. Looking at angles on the axis. Let's consider the terminal arm length 1 to rotate to the angles of 0, 90, 180, 270, and 360, and write the ordered pairs for each. So, if it's at 0 degrees and it is length 1, the ordered pairs would be 1, 0, right? X is equal to 1, Y is equal to 0. If I rotate that up to 90 degrees, now X equals 0 and Y equals 1. If I rotate them again to 180 degrees, so I've made that full rotation. Here, X is negative 1 and Y is 0, sorry. And then I rotate them down to 270 degrees. And down here, X is 0, Y is negative 1. If I rotate them back up, I'll notice that it's at the same point as 0 for 360. Okay, so basically just rotating that through for each of those stops. Okay, so those ordered pairs are important. Now, we're going to fill in the table using the trig ratios in relation to X, Y, and R. Okay, so we're using those points to fill in these angles. Okay, so I have the diagram where I can see it, but we can flip back and forth just so we can see what we're doing. So for angle 0, let's remember up here, sine is Y over R, cos is X over R, and tan is Y over X. So this is the values I'm putting in. For sine theta, so sine of 0 degrees, I would get 0 over 1, which is equal to 0. For cos of 0 degrees, I would get 1 over 1, which is equal to 1. And for tan, I would get 0 over 1, which is equal to 0. Okay? For 90 degrees, I get 1 over 1, because y is 1, as well as r. R is always going to be 1, which is equal to 1. For cos, I get 0 over 1, which is equal to 0. And for tan, I get 1 over 0, which is undefined. For 180, for sine, I get 0 over 1, which is equal to 0. For cos, I get negative 1 over 1, which is negative 1. And for tan, I get 0 over negative 1, which is equal to 0. For 270, I get negative 1 over 1, because now my my y is negative, so it's negative 1. For cos, I get 0 over 1, because my x is 0, which is 0. And for tan, I get negative 1 over 0, which is undefined. Now, remember what we talked about, that tan is, if we thought about r as a line on the graph, it is basically the slope. So when we have our rotational angle is flat, on the horizontal, the x-axis, the slope is 0, right? If it's on the y-axis, the slope is undefined, just like if it were horizontal or vertical lines, because tan is always equal to the slope of that line. And then we'll do 360. Now 360 matches up with 0, so it's going to be exactly the same as what 0 is. So 0 over 1, which is 1, or 0, sorry, 1 over 1, which is 1, and 0 over 1, which is 0. Okay? From these, it's very easy then to find the exact values of the following, because these are either on the x-axis or the y-axis. So cos of 90, if we check our chart, cos of 90 is 0. Sine of 270 is -1, and tan of 180 is 0. Okay, so we basically just used this chart to answer these questions. Okay, alrighty, let's move on. Example 3, solving trig ratios. Now we're solving the following for the following restriction. Theta is greater than or equal to 0 or less than or equal to 360. So now we're given the ratios, and we can use them to find what's going on. So this is using your special triangles. If sine is 1/2, that means my reference angle is equal to 30, right? If I look back at that other page where we have sine is equal to 1/2, that means so that's right here, that the reference angle is 30, okay? So my reference angle is 30. I need to remember my Cos law. So what I want to know is, where is sine going to be positive, because I've been given a positive value for sine? Well, that's going to be in quadrant 1 or 2. So that means that theta is equal to, well, in quadrant 1, it would be 30 degrees. In quadrant 2, it would be 180 minus 30, so it would be 150 degrees. So this is for quadrant 1, and this is for quadrant 2. Okay? So for a lot of these, you're going to have 2 possible answers. Sine of theta is 1/√2, which if we rationalize, as we should, we'll get √2/2. So, and it's positive, so we can use the same graph there. So let's go back and find out where that would be. Okay, so going back, when sine is √2/2, that means we're dealing with 45 degrees, right? Okay, so that's this one. Oops, I'm on the wrong thing. Okay, what was that, 3/2? Yes. So that's what we're looking at. So we've got a 45-degree angle. Okay, so that means our reference angle is 45 degrees. So that means our theta could either be 45 degrees if it's in quadrant 1, right? Or it can be 180 minus 45 if it's in quadrant 2. So that would be 135 degrees. So for these, again, you have 2 possible answers. So let's take a look here on the next one. C. Cos is negative √3/2. So using our Cos law, we want to know, where is cos negative? Well, cos is positive in this one, and it's positive in this one, so it would have to be in quadrants 2 and 3. Okay, so looking back at our chart, if you flip back to your chart, cos is √3/2 at 30 degrees. So 30 is our reference angle, right? So let's scoot back. So our reference angle is 30 degrees, okay? And it's either in quadrants 2 or 3. So that means that theta is either 150 degrees or 210. It's 150 in quadrant 2, because that's 180 minus 30 is 150. Or in quadrant 3, because that would be 180 plus 30, which would be 210. Okay? And again, feel free to draw a picture to help you do these. That really is helpful for me. Tan theta equals 1, and it's a positive 1. So we want to know, where is tan positive? Well, it's positive in quadrant 1, and it's positive in quadrant 2. Now, if you flip back, you will find that the reference angle for tan theta equals 1 is 45 degrees. So if theta is in quadrant 1, that means it's going to be 45 degrees. Or if it is in quadrant 3, it will be 225 degrees. Okay? If it's in quadrant 1, the reference angle is the actual angle. If it's in quadrant 3, you're going to go 180 plus 45 degrees, which gives you 225 degrees. Okay? So remember for these that you're going to get 2 answers. Okay, so here's a little chart, a little piece of information for how to approach these. 1, use exact value to find the reference angle. So have that chart handy. Okay, that chart's very valuable. Then use the cast rule to determine which quadrants the rotational angle lies in. Probably 2. Okay, and then calculate the rotational angle. You know, and I suggest, my big tip is sketch, draw. Okay, use your brain to figure it out in that respect.